Hi everyone. Today I'm going to go over logarithms. Logarithms it's a useful tool in mathematics that you use to undo exponents, and I'll get to that in a second. So the rule for every log base a of b equals c, then a to the c equals b. Um, you're probably thinking, well, what does that mean? What it means is that the logarithm is a way to basically undo exponents. It's saying a to the c power equals b. When you're doing a logarithm, for example, log base 2 of 8, you're saying I need to raise this base of 2 to what power to get 8. And the reason why that's important is that oftentimes in algebraic problems, you will get, you know, 3x plus 6 equals 24 minus 3x, and then you'll get, you know, 8. You'll reverse everything and solve for x. The only problem is that sometimes an x will be the exponent itself, such as in a problem like this. Let's check out this algebraic problem. You divide by 3 on both sides, you get 2x equals 8. So how do you get the x? The x is up here in the exponent itself. And that's why a logarithm exists. That's when you would do log base 2 of 8 equals x. That's when you would use an logarithm. When the x is trapped up in the exponent itself and you need to find it. Yeah, that's the introduction. Let's go over the rules for logarithms. Let's do addition first. I'm going to even write addition over it to show that we're going over it. So the rule for logarithms is log base a of b plus log base a of c equals log base a of bc. The rule here is log base a of b plus log base a of c equals log base a of bc. Let's turn it into an example. So when you're adding logarithms together, you're multiplying the outputs. So an example of this would be log base 2 of 4 plus log base 2 of 8. In this case, a is 2, b is 4, and c is 8. So let's like translate this. Log base 2 of 4 is 2 because 2 would be raised to the second power to get 4. And log base 2 of 8 is 3 because I went over that earlier, and you would have to raise the base of 2 to the third power to get 8. So if we follow the rule here, this would be equal to log base 2 of 8 times 4, which would be 32. And we know from adding up the numbers down here that we would get 5. So log base 2 of 32 is also 5 because 2 to the 5th power, this base 2 raised to the 5th power would equal 32. So that's why it works, this rule of adding logarithms, because what translates to just normal numbers here translates to, in these little inputs, multiplication. Yeah. Next, we're going to do multiplying. And the multiplying rule, multiplication. And the multiplying rule is as follows. A times log base b of c equals log base b of a to the c. Or c to the a. Sorry. So the way this works is we'll employ the example of 2 times log base 5 of 25. Now you may think, why is log base 5 of 25 the same as log base 5 of 25 squared? And the reason why that is because of multiplication sort of being like repeated addition. And that's like true. Multiplication is just repeated addition. If you look at 4 times 3, it's equal to 4 plus 4 plus 4. 3 times, which is 12. And it's the same for 3 times 4. 3 plus 3 plus 3 plus 3, 4 times equals 12. Multiplication is repeated addition. The same way that exponents is repeated multiplication. So the way this translates is 2 log 5, base 5 of 25 is equal to log base 5 of 25 plus log base 5 of 25. So when you translate this out into addition, this is where the addition rule comes in. So it's equal to log base 5 of 25 plus log base 5 of 25 equals log base 5 of 25 times 25 from the addition rule from earlier. Since addition of normal numbers, when you finally get the whole thing together, is multiplication in these little inputs like 4 and 8. That's equal to the multiplication here of 25 times 25. And since a multiplication of a logarithm is just repeated addition, it actually translates into full-blown exponents, because you know the same thing is just going to be added to itself over and over again. So that's the same as log base 5 of 625. And that is 4, because 5 to the 4th is 625. And if you want, well, I'm gonna translate this into the actual answers. Log base 5 of 25 is 2, because 5, this base 5 raised to the second power is 2. And log base 5 of 25, once again, is 2. And this is equal to 4. So you can see that when it comes to these inputs here, multiplication inside is addition out there. And the core reason of why that is that when let's look at PEMDAS. To find our answer. See, logarithms aren't really in a part of middle school and elementary school math, so no one ever puts logarithms up here, but logarithms are at the same level of exponents. So the same sort of algebraic rules that apply to exponents apply to logarithms. Like, remember how I think last semester we did this, x to the third times x to the second equals x to the 3 plus 2, x to the 5th. When you are multiplying exponents with the same base, you just add the exponents themselves together. With logarithms, it's the same, but a little reversed. When you're adding logarithms of the same base, you multiply the inputs instead of adding exponents that are being multiplied. So if they're not really the inverse of exponents. Logarithms are more like the converse. And it's this way of just algebraically undoing an exponent when you are in like a fixed. So yeah, that's it. If I was unclear in any way, I apologize. Bye.